friends, welcome to the part 2 of the Fourier series. Today, we would like to discuss when the Fourier series exists. You know the Maclaurin series expansion, Taylor series expansion, correct? Sine function can be expressed in series form also. E raised to x function means exponential function also we can express in series form. Then, today we want to discuss when the Fourier series exists and what is the definition of the Fourier series. Okay? So let us see. Fourier series. The Fourier series of the function fx exists only if the following conditions are satisfied. The first condition, fx must be periodic. Means here fx is periodic. What is the definition of periodic function? The definition of the periodic function is f of x is equal to f of x plus 12, where 12 is the period of the function fx. If we use the notation p, then here the value of p is 12. Okay? For example, sine function. Sine 2 pi plus x. What it is? Sine x itself. That means period of sine function is 2 pi. If you want to see graphically, then sine 0 is 0. Sine pi by 2, it is always 1. Clear? Sine pi, it is 0. Sine 3 pi by 2, it is minus 1. And sine 2 pi, it is 1. Means on x-axis, the points are 0, pi by 2, pi, 3 pi by 2 and 2 pi. Okay. Here on y-axis, there are two values, 1 and minus 1. Now draw the graph of sine function. Sine 0 is 0, sine pi by 2 is 1, then sine pi, this is pi. Sine 3 pi by 2, it is minus 1, sine 2 pi, it is 1. Roughly, I draw the graph of sine function. Means total cycle of this sine function is 2 pi. Clear? Now, same portion is repeated. Means again here, we get like this from the right hand side, similarly on the left hand side. Correct? Means same cycle from 0 to 2 pi. Same portion is repeated. Therefore, the sine is periodic function with period 2 pi. Okay? Now, the second condition for the Fourier series is the function fx and its integral are finite and single valued. The most important condition is the fx must be that means its integral value must be a finite. It never be infinite. Okay? The third condition of the Fourier series is fx has a finite number of discontinuous. That is, fx is piecewise continuous in the interval c to c plus 2 pi. You know the meaning of continuous function. Without taking pen offside, if you draw a graph, it is continuous. That means fx has a finite number of discontinuous. That is, fx is piecewise continuous in the given interval. The fourth one is fx has a finite number of maxima and minima. That means if there are maximum value of the given function or minimum value of the given function, then it must be a finite, never be infinite. Finite means you can count it. Okay. This condition is also known as Dirichlet's conditions. If you enjoy my video, then like it, subscribe it and share it. Thank you.